Tonight is the 121st Hot Science School Talk with Dr. Moriba Jah of the Department of Aerospace Engineering here at the University of Texas at Austin. Now let me tell you a little bit about him. From the time he was 6 years old, he grew up in Venezuela, where he attended military high school. And after he graduated, he joined the US Air Force. And one of his jobs was guarding nuclear warheads as part of the military police. He got further out into space when he was in college and graduate school at the University of Colorado at Boulder. He studied aerospace engineering, which is kind of a fancy way of saying he became a rocket scientist. He worked at the Jet Propulsion Laboratory on several missions, including helping put together the navigation for the Mars Global Surveyor, the Mars Odyssey, and the Mars Exploration Rover. Among the many honors Dr. Jah has received for his research and service was the NASA Space Act Award, which is given for the creative development of a scientific contribution of significant value in the advancement of space and aeronautical activities. That's quite an honor. It stands out amongst the many that he's received for his research and service. And tonight he's going to tell us about how space, the final frontier, is the newest frontier in terms of sustainability. Please join me in welcoming Dr. Moriba Jah.
Brother. How are people doing this evening? Woohoo! What? All right. So first and foremost, I want to say that I'm very honored to be here, and you could be doing many other things that's not being here, but you're here, and so I value that, and it means a lot to me. I see some familiar faces in the room, but I want to talk to you about this issue called space sustainability, and not a lot of people are kind of couching it in this way, and so let's see what we can go through here. So I'm going to talk to you about satellites. Who cares? What are these things about? What are these things that are on orbit? What's the problem that we're facing in space right now? This thing called space situational awareness. Why? What? How? Some of the challenges that we face, and then some examples of some pretty cool research that we're doing here at UT. So satellites, so what? So what? Blah, 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 stuff in space, who cares? All right, so I know a lot of you probably have cell phones, right? And if you want to get from point A to point B, you're kind of looking at this blue dot. It's telling you turn left, turn right, gives you position, navigation, timing, tells you where you're located, and not only does this help you figure out kind of where you are, but people use it to figure out where other things that they care about are, right? Like aircraft, boats, ships, other vehicles. I have relatives that, they're in the trucking business. They keep track of where the trucks are located. So it's a big deal. I don't know why that thing's like in the middle of the ocean, but don't pay attention to that. That's just, cheesy cartoon I got online. What else? Weather. Weather's kind of a big deal. I mean, imagine if the only time you knew that some sort of impending doom was based on you just kind of looking out the window. Not a whole lot of reaction time. Can't really pack your bags real quick when you see, skies are getting dark, I don't know what's going on, all of a sudden 100-mile winds. It could be too late. Line of sight for you is very short compared to line of sight for something that's in space, right? But not only is it just the visible stuff, satellites can actually collect data in different wavelengths, different frequencies. They can detect things that the human eye just wasn't built to do, and things that are very informative at other wavelengths and frequencies. But not just weather stuff. Agriculture benefits greatly from space-based technologies. Being able to see where are the nutrients that are beneath the surface. Where can I grow this or that crop? Where does it make sense for me to plant this, that, or the other? These are things that are greatly enhanced and can benefit from space-based technologies. Okay, let's go away from agriculture. Education. All of us in this room, we can go to a school, we can get good education, we can learn about this sort of stuff, we can come to meetings like this, right? But not everybody on the planet has access to that. And space-based technologies are allowing people that otherwise would not get the benefit of education. How important is this whole education thing? Well, quick story. One of the things that really changed me when I was going to school, specifically in high school, was that when I was studying physics, I was able to learn, wow, I know on my own, I can now figure out if I see some object that is traveling in this direction, and if I can observe it and I can time things, I can figure out its trajectory, I can predict where it's going to be, I can figure out how high of a building it fell off of. The fact that I could figure things out on my own was something extremely empowering to me, that I realized nobody could take that away. That was mine. That was mine. To provide that to people everywhere. Priceless. That's a space-based capability that allows that. All right, let's get more into your pockets. Banks, okay? Transactions. The timestamps on when transactions occur, routing of information between banks. You go to some nice little village in Italy, you go to an ATM, you want to get some cash because you want a little vino rosso or something, you can't do it? That would not be so good. So what if satellites just disappeared? Well, based on all the things that I just explained, I can tell you that, I don't know, when's the last time anybody actually opened up a map and used the compass? I can tell you, I mean, that was a long time ago for me, all right? People in the Navy, they probably are taught, here's this thing called a sextant. Sure, you can figure out where you're at, look at the position of the sun, and I'm sure that they can look at that in a museum, but I'm telling you this, if satellites disappear, technology as we know it, life as we know it, goes back decades, okay? Major things would stop working. If you think that's not enough, just think riots. Ooh, not so good. So we don't want satellites to disappear. So, all right, what are we really talking about in terms of population of stuff in space? Well, it turns out that the largest database of stuff in space is maintained by the US military, and it's about 26,000 objects ranging in size from your cell phone all the way up to the space station, okay? They're in different orbits. We'll show you a little bit of that. And, you know, basically what you see, this plot here on your left comes from NASA's Orbital Debris Program Office at Johnson Space Center just down the road in Houston. And as you see, this thing is increasing as a function of time. Right here, the Chinese blew up one of their satellites in orbit, in a high enough orbit, so that created a bunch of junk. And then two satellites, Iridium and Cosmos, collided with each other. That created a bunch of junk, so that those are these kind of steps that you see there. But out of about the 26,000 objects, about 2,500 at this point are things that work, and everything else is garbage. But that's not really the bad news, okay? Here it says assumed space object population. If you go down to things that we believe are down to the speck of paint, kind of millimeter level stuff, you're talking about 500,000 objects that could be a hazard to these critical space services and capabilities that I just described. A speck of paint traveling at the right speeds. There's this thing called kinetic energy, mass and velocity. Bullets are small but can do a lot of damage because they're going really fast. So imagine a speck of paint, small mass, traveling at 10 times the speed of a bullet, penetrating one of these satellites. Worse yet, so today was a historical day. Anybody know why? Tell me.
First female spacewalk.
First female spacewalk. Woohoo! Clap for that, clap for that. Give it up, give it up, give it up, give it up. All right. So the thing is, nothing guarantees that these astronaut crews are going to be safe, because we can't track stuff as small as a speck of paint. So this is just kind of random bullets flying around that we just hope don't meet us on orbit. So starting with Sputnik in 1957, this gives you an idea of the growth of the space object population. It's provided by Analytical Graphics Incorporated. And so they've put this movie together. So things are getting more and more populated. We have these highways in space. Most of the stuff that we put up there never comes back. Things die on orbit. They just continue adrift, and we just send up something else, and something else, and then something else. Yikes. Yikes. Swarms of stuff. And this is just the stuff that we can track. There's lots and lots more stuff that we can't. So, what contributes to this stuff? Well, so these aren't just whole satellites. Once things get old, space gerontology is a thing that I'm making up right now, right? At some point, these things age. They get brittle. Glue used to put things together. Glue is not meant to last forever. Things delaminate. Things break up. Sometimes two objects will meet each other and collide and produce more stuff. Every once in a while, an object will blow up and produce more stuff. Worse yet, some people might destroy their own satellite on orbit, and that creates more stuff. Here's an example between Iridium and Cosmos, also from Analytical Graphics Incorporated. Iridium is call it a constellation of satellites in low Earth orbit. This happened in 2009. And Cosmos is this dead satellite. Cosmos couldn't get out of the way. Yowza. Right? This is not good. We don't want these things to happen. And the thing is, these things do. Just look at the massive amounts of objects created as a result. And now these things just swarm the planet. And these things happen. We detect when these things happen every couple of years, but it could be happening more frequently. There's still some science that needs to be done. But that's just bad news. Now you got this train of stuff that you got to worry about. Couple that with all the other space debris, and you can see that we can talk about going to the moon and Mars, but we got to penetrate through this wall of stuff to get there. And most of it, we can't figure out where it's at, where it's going. Not so good. So one of the things that we've kind of developed here at UT Austin is this thing called Astrograph, and I'll talk about it more a little bit later, but basically it's kind of this crowdsourced space traffic monitoring system. So you can actually go on your cell phone or whatever and Google this and see it, but basically we bring in multiple sources of information and we represent that kind of in this common framework. And just the color scheme here, to put things in a context, are the things in orange or this yellow color are things that work and everything else is some shade of garbage, okay? So there's a lot of trash. So out of 26,000 objects, about 3,000 work, everything else is garbage, so about 6% of what we track is garbage, and we only track 1% of the stuff we should worry about. The story does not get better. So, there is a gold rush happening right now. People want to put a lot of stuff on orbit. These are the planned launches in the next few years, and you can see SpaceX, OneWeb, Blue Origin. There's this thing called the internet. I think you've heard of it. And the internet is moving towards being a space-based service. So these people want to make a good chunk of money by providing global internet from space. Look at the number of objects here. About 1,600, 400, blah, blah, blah. So if you look at the news and Google Starlink and SpaceX, you'll see that Elon just requested licenses for 30,000 satellites in the next few years. So currently we track a total of like 26,000 things. He wants to basically add 30,000 in the next few years. Yeah, where do I sign up for that, right? Here we have number of satellites as a function of altitude. And if these things were all scattered right, away from each other, that would be one thing, but there's some overlap. How are people going to coordinate the traffic up there? So what is the problem, if you didn't get it quite yet? There are pretty much little to no rules when it comes to what's going on in space. There's no deeds. There's this thing called the Outer Space Treaty. It says res communis, which is global commons, right? Space doesn't belong to anybody. It belongs to everyone, kind of thing. But we all know two things can't occupy the same space at the same time. When they do, bad things happen, right? So the thing is, first to orbit, it's like squatters' rights, right? As soon as you kind of take hold of an orbital regime, that's yours. There's a potential to make lots and lots of money. There's a gold rush going on. Here's the cool thing that Elon and a couple of other people have done. They've made space more accessible. That's good. Kind of like transcontinental railroad connecting east to west coast, right? Good for commerce. But we need to be careful about the responsibility that goes along with easier access to space. And the thing is, there are no space traffic rules. So we have rules about traffic on Earth. I travel around the globe quite a bit. If I go to Australia, if I go to Scotland, Germany, I get in a car. Red light kind of means the same thing in these countries, right? The way you turn left, right, that sort of stuff. Okay, maybe the driver's seat is on the other side in a couple of these countries, but kind of the rules of the traffic are very similar. In the air, we have traffic rules as well. Two planes, if you're in your aircraft and you see another aircraft and that aircraft isn't moving left or right with respect to you, guess what? It's probably coming head on. So they know, pilots know, yeah, bank left, right? On the ocean, they also have rules of thumb. There are no rules of thumb for stuff in space. In fact, about 4 weeks ago, if you look in the news, you will see that there was a predicted collision or near miss between one of Elon's Starlink satellites and a satellite from the European Space Agency. And the European Space Agency tried to contact SpaceX, sent emails, that sort of stuff. Look it up. SpaceX said, sorry, we had a bug in our email. We didn't get it. The dog ate my homework kind of thing. And the European Space Agency moved out of the way. That's not a good recipe for how this doesn't scale well to 30,000 objects, if you see where I'm going with this, all right? Not so good. So, interestingly enough, in looking at the environment and thinking about sustainability, in my travels, I've met indigenous people around the globe, and on a trip that I took to Alaska some years ago, I took my son Denali to Denali, not the actual mountain, but the park. I'm not that brave. I'll call it bravery. And I saw a big disparity between natives and the rest of us, and ecosystem kind of degrading, right? And one of the things that I got attuned to was that there are indigenous people on the planet who have thrived for thousands of years striking a balance with their environment. They've understood what sustainability means. They've understood you can't overfish, you can't overhunt, you can't do this, that, or the other, right? And a lot of the tenets of these people are captured in this thing called TEK, or Traditional Ecological Knowledge. And so I've tried to interpret some of that for space. One of the tenets is do a lot of observations of your environment and try to understand relationships between you and all these things in the environment you're in. So far, we have no taxonomy where there's no classification scheme for human-made objects in space. We need to develop models physics, that sort of stuff, based on empirical evidence. Sustainable use of resources, management systems, okay? We need to do a better job with registering objects, sharing information. Right now, the United Nations has a registry, and they say, eventually you need to get your objects registered. China registers stuff every so often. They register several hundred things at a time. Other people wait several years before they register their objects. When they register something, some people put this information, but not that. There's no standard. That's not so good, okay? That doesn't help. There's no global pot of information that's shared. Coordination, this whole thing about the email, that's not so good. Past and current uses, that relationship with the environment, that historical relationship, right, with the US, the Apollo program and what we did there and how that's developed over time feeds into that sustainability. Ethics, values, coming up with norms of behavior, right? The United Nations has the Committee on Peaceful Uses of Outer Space. I've had the honor of being able to go to the UN on the US delegation to participate in that in Vienna. The UN has prevention of an arms race in outer space in Geneva. I've participated in some space security meetings in Geneva related to that. Cultural relationships. Anthropological cosmology, which really means kind of societal relationship with the space domain. What do we feel obligated to do? What are our beliefs? What do we believe in terms of, what are our interpretations of our existence and where life comes from and all that? So all of these things are captured by traditional ecological knowledge, and I believe that this is foundational to try to apply this to sustainability. I kind of laugh a little bit when I hear people say, oh, we're going to send people to Mars. Okay. And then you see that, yeah, we're going to put this dome in the middle of the Atacama Desert and like enclose people for like 6 months, this biosphere thing, and see how they do. It's like, if you want to know what it is to be in a harsh environment, talk to the Inuit. They've been thriving for a long time in a place where you would say, why is anybody trying to live here? And they thrive. So trying to just make this stuff up in the absence of knowledge that already exists doesn't make sense. I would say it's not scientific. So if we had to put together this Venn diagram of all the things occurring in space, the set of all stuff, that set as a whole is not knowable. Because, I don't know, if anybody feels that they know everything, talk to me afterwards, because I have some stuff I want to talk to you about. So out of the set of everything happening in space, there's a subset of things that we believe, and there's another subset of things that are measured, and all three of these things don't coincide exactly. So there are actually things that we believe that are impossible and aren't real. Because, well, talk to the Flat Earth Society people, right? I mean. So we make observations, we infer things, we come up with models, but it doesn't mean that we're exactly correct. So that's why that extends outside, because there are actually physics that are not actually happening. And when it comes to evidence, the truth about every sensor is every sensor lies. There's no truth sensor, okay? No sensor outputs the exact truth. It outputs something that might be related to it, and sometimes it outputs something that has nothing to do with the truth, okay? So that's why that extends outside of that. When our beliefs and the evidence coincide, then that's actual inferred knowledge. And that's the stuff that we thrive to get. So in terms of this traditional ecological knowledge, we have ethics, norms of behavior, kind of moral code, judgments on certain behaviors. In terms of practice, trying to share data, managing the traffic, the skills that we use on orbit, respect for other people, other cultures, techniques that we use to try to do the best job possible of being safe, the knowledge that we acquire through empirical observations, the physics, understanding the environment. And where these things overlap That is foundational to traditional ecological knowledge. All right, so there's this thing called space situational awareness. What is this thing? SSA. And it's really decision-making knowledge about stuff in space. So we start off with a space environment. It's kind of harsh. The environment can upset electronics in the satellites. Materials age, I told you about the satellite gerontology kind of stuff. So effects and impacts of the environment on objects is something that we really have to understand. But there's some hazards. The paths of objects are only approximately known. We don't know these things exactly because our measurement systems aren't exactly true, right? Space is more crowded. You saw the video. You saw how these things are building up. Space objects can be hazardous to each other. We saw the collision between Iridium and Cosmos. But every single domain of human activity has experienced malintent. To think that space is just going to be a place of benevolence is naive. Let's see. How do we behave on the oceans? Well, everybody here has heard of a pirate. How do we behave when people crossing across lands mostly unmonitored? We've heard of banditry. So to think that in space it's like, oh, we love everybody. That's not the case. So we need to be able to monitor and understand that. So what does this space situational awareness need to provide? 3 things: transparency, accountability, and predictability. Transparency. We need open and accessible information. India, very recently, blew up one of their satellites in low Earth orbit. India said, all the pieces of debris will re-enter in 45 days. Jedi mind trick kind of thing. Those aren't the droids you're looking for. The US says, we have evidence that there's stuff that's going to be up there for a very long time. I don't know. Do you have the data? Did you check? I haven't assessed that. And so there's a lot of he said, she said. That's not good. Evidence is strong when it can be independently corroborated. So we need a common set of data that's accessible by lots of people, okay? Accountability. We have to be able to monitor the behavior of folks and build this body of evidence and say, I saw you do this thing and it resulted in something that was harmful. Predictability. If I know where a satellite is going to be 1 week from now and I figure out it's going to be close to me, that gives me time to plan, to get out of the way, to behave in a way that's safe. So communication is a big deal. Accurate and precise modeling of the physics is a big deal. But I have cultural competency. What does that mean? Let me tell you. The United Nations Committee on Peaceful Uses of Outer Space just adopted 21 guidelines for long-term sustainability of the environment. These are not legally binding in and of themselves, but if all 90+ countries that signed this stuff, if they made it space law and enforced it, that would be good. But hold on. Would everybody interpret the guidelines the same way? And the answer is no. What is Sharia interpretation of the COPWA's guidelines? Do Jewish people maneuver their satellites on Shabbat? How do Americans behave in space? I can tell you one thing right now. Americans, we try to avoid maneuvering satellites on weekends and holidays. Yeah, I don't want to come into work on a weekend and holiday to do that. So Americans maneuver their satellites on Tuesdays, Wednesdays, and Thursdays. You don't want to do it on a Friday because the maneuver didn't go off right. I'm sorry, honey, I got to stay at work late. You don't want to do that. And you come back fresh from the weekend. That definitely does not want to be the first thing that you want to do when you get to work. So Tuesdays, Wednesdays, and Thursdays, the great days for Americans to maneuver. But it doesn't mean that other countries have to do that. So there are cultural aspects of how we behave in space, okay? Essential ingredients for success. In all my travels, I can tell you, people want independent assessment of the behavior. They don't want one czar. They don't want, the U.S. is going, you're just going to trust the United States. Really? Yeah, I'll just leave it at that. okay? We don't have sustainability metrics. One of the things that we're trying to develop here at UT is a space traffic footprint, kind of analogous to a carbon footprint. I'll talk about that here in a little bit. And there are some best practices and standards that are developing out of the United Nations, out of ISO, which is like this international standards organization, that sort of thing. All right. So, space traffic footprint. Loosely, think of this as the burden that any given object poses on the safety and sustainability of anybody else, okay? So when I get into my car, and as soon as I turn that thing on, I'm in my driveway, right? I'm starting to back up. I am a burden to any other pedestrian and other driver, right? Basically, other pedestrians and drivers have to take me into account to stay safe. That burden is what I'm calling the footprint, okay? If we can now quantify this burden on every single object, dead or alive, that'll be a good thing, because then you can put a bounty on an object and say, hey, $10,000 to clean that piece of junk up. Why? Because it has this space traffic footprint. Or space insurance. Hey, charge these people a lot more money because their footprint is a lot larger. But without the metrics, we don't get there, okay? Has to be independently measurable, has to be something that people can compute all over the place, has to be repeatable, consistent, all the things that the Flat Earth Society people don't believe in, right? I bring this stuff up because, you chuckle. People email me like at least once a month to argue with me about the whole Flat Earth thing, so I think it's funny. But in any case, so I just, how maneuverable is a satellite? How trackable is it? How well designed is it? Is it in an orbit that if you just leave it alone, will it re-enter on its own? So I'm working with the World Economic Forum right now with a team with MIT, Bryce Technologies in the United States, and European Space Agency to come up with a space sustainability rating where we can fold in this idea of a space traffic footprint. All right, so we have a few challenges. Space environment, it's harsh. The sun is doing lots of stuff, there's charged particles, it's a harsh environment, so we need to really understand that, the effects and impacts of the environment on our objects. Anomalies happen all the time. Satellites stop working. Why did my satellite stop working? Was it because the sun had a hiccup? Or because Jimmy doesn't like me so much and did something to me when I wasn't watching? It's hard to tell the difference. And as long as it's hard to tell the difference, people can act and react in ways that we don't want to see happen, okay? There's a storm in Halloween 2003. If it weren't because people talked to each other, people could have said, oh, am I being attacked? Is it a cyber attack? Is somebody jamming me? Confirmation bias. We all do it. We're all culpable. Mea culpa, mea culpa. But people come up with data and tests that are self-validating, right? It's what I call the self-licking ice cream cone. It's really awesome. I'm so good at this. We don't have standard benchmark data sets that we can just provide to people so that we can have kind of apples to apples comparisons. That's not so good. Remember I told you about this idea of truth? What happens when we make decisions based on incomplete data? That thing is a circle. No, it's not. It's a square. People will fight over this stuff. This is the importance of combining information and sharing information so that we can each gain the perspective of the other. Because we don't know everything. We don't have the whole stuff. Astrodynamics 101, things that make objects move in space, because I couldn't let you leave here without telling you about this. There's this thing called the Earth. It's fairly round. It has this kind of effect that we call gravity. There's the moon. It's big, goes around about every 28 days. It also has this effect we can call gravity. There's the sun that has this effect as well. Somebody made fun of me not too long ago, say, hey man, are you stupid? What? The sun has gravity? They took out a lighter from their pocket and they flicked it and they showed me the flame and like, oh, it's fire, man. There's no gravity in the sun. Okay. Photons from the sun interact with different surfaces, push the satellite in different directions. Things heat up. There's re-radiation. There's re-radiation from the Earth. reflected photons from the Earth. Antennas communicate. There's power stuff. This thing called tides, relativity, other planets. So, understanding a population, you have to tag and track individuals. If you want to understand hyenas, you tag a few individuals, you track them, and you see how these things interact with other hyenas and the rest of stuff. Whales, the same thing. Birds, similarly. What do you do with all the stuff in space? You can't tag that stuff. You can't just go up to it. So that's an issue. That is an issue. So basically, we have an identity crisis on orbit because most of these objects don't report their identity. So at different times, you see different numbers of dots in different places. How do you put a first and last name to those things? That's the challenge. We've come up with these knowledge graphs based on these things called ontology, semantic relationships, trying to build up information, this idea of big data, to try to discover stuff that otherwise would not be discoverable. We've come up with these ways to link information together and try to do these sorts of queries and very complicated things and trying to do clustering analysis to see how we can find populations of stuff that have similarities with each other. So here's an example of something cool that we're doing here at UT. I call it BISER because I like acronyms. Anybody know what TLA is? 3-letter acronym for 3-letter acronym. Good job. All right. So, biometrically inspired space object recognition. So, in biometrics, you have 3 kind of processes. Enrollment, verification, identification. Enrollment, let's say fingerprint, put your finger on the sensor, it collects data, says, okay, I have enough, take your finger off. Takes the data, puts that aside, stores it as alleged template for Moriba Jah. Then says, put your finger back down, verification, collects data. So, okay, collected enough. Let me compare these to this template that I just created. If it seems to match sufficiently well, then you're verified. Store that in a database of templates. And at any point in time in the future, when I put my finger down, it's going to compare the data it collects to every single template in the database. And hopefully it gets one-to-one match. That's what we're looking for. One-to-one causal relationships. So, very briefly, there's these things called light curves. The sun, photons, basically shine on objects. The different surfaces of the object reflect light. People on the Earth can see these things, and they look like spikes of light as a function of time. Here's a satellite called Topex. It's spinning, it's dead. Here we've collected spikes of light as a function of time. So I just had to have this sort of thing just to kind of show you the way that kind of light interacts with different surfaces, but this is what we got. This is real data that we got on Topex, and you can see some spikes as a function of time. And so what I told my team is, all right, if you can figure out the orientation of thing as a function of time, imagine that this thing is encased in a unit sphere, and now you know from the frame of the body where all these photons were reflected. Build me a heat map on the sphere and unfold that into this 2D representation called a Mulvide projection right here. And guess what? Topex seems to have a face. It has a nose, it has ears. So some set of satellites have persistent features. Here we have Topex on one day, Topex on another day. Do they look identical? No, but I can see some stuff that persists. So maybe we can apply facial recognition techniques and iris recognition techniques in this manner to start classifying objects and putting a first and last name to these things. What are the cool things about doing stuff at UT? We're fairly unrestricted as academics to do research and things that we're intellectually curious about. We can develop state of the possible type stuff, not just state of practice kind of things. Track 2 diplomacy, what does that mean? It means I can work with people from Russia and China and it's okay, because I'm not a US government official. And that's a good thing, to work with people from other cultures that maybe government to government you're disagreeing, but as scientists, you can develop bodies of knowledge together. And then this idea of a modern workforce. I told you 30,000 satellites that Elon wants to put up there, right? So here's what I want. I want UT to become the Hogwarts for space. Hogwarts for space. So, what do I mean by that? I mean, I'm an astrodynamicist, but there's this thing called the Robert Strauss Center for International Security and Law. There's a space security and safety program that I lead there. I'm mentoring 2 law students there. There's this thing called environmental science. So we're thinking about having the space sustainability program, maybe developing something like that, right? I told you about anthropology. There are all these different parts of the campus. This problem is transdisciplinary, meaning it can only be solved by the fusion of all these disciplines. We can't just have stovepipes of excellence. These things need to be combined, and UT is a great place to do that. Who cares about this stuff? Well, you have chief scientists of the Air Force at some point, some folks from DARPA, NASA, FAA administrator for commercial space transportation, people in the Department of Defense, in the Pentagon. NASA's current administrator, Jim Bridenstine, cares about this stuff. Martha McSally, representative from Arizona. Need I say more? Brian Babin, also represented here from Texas. This is me at the House talking about some of this stuff with a panel of people, showing you some of the same kind of plots. President Mata Bio from Sierra Leone, met him in April. He wants me to come out to Sierra Leone to help Africa start developing some of these technologies. Al Gore, who has this whole climate change thing, but he needs to be kind of sweetened up to extend environmental protection to space. At the United Nations, talking about this stuff. In Australia, the Australians care about this thing too. TED, I gave a talk on the big TED stage in April, and it's not enough. It's not enough. I am not enough. That's why I'm here doing this talk. To raise a little bit of awareness of the problem that we face, the same stuff that we're doing to the oceans with the plastics, we're doing to space. And what I'm saying is that I'm not enough. And we need help. We need more people engaged in working in this stuff. Thank you very much.
Nice way to go to ask your questions. There's already a whole bunch of them. All right, so the first question comes from Quilly Nelson the Hedgehog. Thank you for that creative name.
I love that, love that. The answer is no. Yeah, I'm just
His question is, can you send the satellite out to space to attract space junk like a big magnet?
So it turns out that a lot of the stuff up there isn't really magnetic, but people in the European Space Agency have this program called Clean Space, and if you Google it, you'll see that Surrey satellites, they've tested two technologies on orbit. One is a harpoon and the other one's a net. I can't make this stuff up, really. So, yeah, harpoons and nets.
All right. The next question comes from Tacodile, who asks, will the trash ever come back to Earth?
Most of it will not. Most of it will not.
Matthew Irwin asks, if we keep sending satellites to replace the old ones and keep on sending stuff into space, will there be a time when there is too much space junk for anything?
And the answer is maybe. This is what we call a tragedy of the commons, right? Is that when we have a common environment that's a finite resource and everybody is using it just any which way they want without really taking into account the environment holistically, it gets to the point where the environment could become unusable. And that is a real possibility.
Well, Kara asks, what's the most common piece of junk found in space?
The most common
piece of junk.
Well, the biggest ones are rocket bodies, dead rocket bodies, and those are the ones that you probably want to remove first because when they explode, they become many more pieces. So large things become many more smaller things, so you probably want to remove that stuff first.
Matthew Irwin asks, variations on a theme. Can we'll be able to clean the space junk. Can we use a high energy bomb or some sort of electromagnet? So there's the magnet thing again. But
Yeah. So things that go boom, we want to stay away from for reasons that I explained. So we don't want to blow anything up because that usually creates a lot more stuff. So if possible, if we could find ways to maybe nudge things into orbits that are like naturally cleansing over very long time periods, or if we could put things put devices that make these things have larger areas so that so-called non-gravitational forces make these things re-enter more quickly. Like, these are good ideas, I think.
Cool. Next question comes from Sad Satellite, who asks, I heard somewhere about a plan to make a huge space net made of super strong material that would wrap up space junk and fall back to Earth. Would that work?
Indeed, and Surrey Satellite Systems tested that just last year.
Very cool. So KDT asks, well, it's not really ask, it's a statement. My idea, a really big space Roomba.
So I would say this, right? Roombas can be good and not so good. I've seen Roombas be very effective, but I have pets. I'll leave it there.
When a satellite is being anonymous, asks this, what would be an Inuit approach?
If a satellite's being, say again?
So anonymous asks two questions, and I'm asking the second one first. What would be an Inuit approach? How would the Inuits approach this problem?
You know, just doing at least some kind of cursory investigations on like traditional ecological knowledge, for sure, I think the approach would be, right now, a lot of people just want to, they're in desperation mode. They're like, we need to clean stuff. We need to come up with the technology to remove stuff. I think the Inuit approach would be, we know that there's a problem, but we need to observe enough and really understand what's going on before we do anything. Because the potential of us doing harm by not understanding the problem first far outweighs just being patient and just being able to understand things a little bit better.
Cool. Anonymous also asks, why do countries blow up satellites?
Well, if you hear the reason, it's to demonstrate that there are superpowers in space, but I don't call creating more junk superpower. I would say superpower is showing that you can clean the stuff up, that you don't pollute, that you look out for other people. To me, that's superpower material right there.
Anonymous has the most questions tonight. Their next question is, how do we convince policymakers to support transparency, accountability, and solutions? So clearly you've spent a lot of time with policymakers. Have you gotten a sense for what it's going to take?
What it's going to take is being able to collect enough information, reverse engineer things, and show them that even if they try to hide, they can't. That's the way to do it. You're just not going to just convince people to just fork over information. You have to show them that it's an exercise and it's futile to do that.
This question comes from someone called the USSR.
Hold on, man. Really? Hold on. Yeah, go ahead. All right.
Why did you want to study space?
Well, when I was really young, the whole Apollo moon stuff is a very foggy memory for me. So to me, the first real memories of space shuttle, Sally Ride, that sort of stuff. Those were my days, shuttle. That brought me a lot of kind of inspiration, wanting to be an astronaut and these sorts of things. But I thought, that's for smarter people, not somebody dumb like me. And then when I served in the military, I was in Montana, big sky country, which I call nothing but sky country. At night, guarding nukes, I could see dots of light going over the silos, and I'm like, hold on, that's not a plane, it's not a shooting star. Wow, I can like see satellites. And that's when things connected for me.
Why do you think space sustainability is just now being realized as a thing?
I think that people have been talking about debris mitigation and not creating more pollution, but nobody's really been talking sustainability until recently. And I think the wording and the narrative the perspective needs to just change a little bit. The way we look at it in terms of preservation of kind of the pseudo ecosystem, I think just now people are starting to be able to make analogies looking at what we're doing to oceans and our lands and extending that to near Earth space.
The next question also comes from Anonymous and asks, what education do you recommend for a future space activist?
I talked about this being a transdisciplinary problem. That pretty much means anything that you study, you could probably apply in some way, shape, or form to space. So whether that's studying government, public policy, law, aerospace engineering, astronomy, you name it, anthropology. There's something related to space that you could apply that to be a space activist for sure.
Next question comes from Yash, Y-A-S-H. Is there a way to put satellites in an orbit that can bring them back into a safe place to be destroyed without leaving a trace?
I'm going to have to file that next to the 1.21 gigawatt flux capacitor. Satellite, put it in an orbit that it can come back and be safe to be destroyed. I don't even know what that means. I'm going to have to think about that for a while.
Okay.
Yeah.
Next one comes
Makes
from...
me dizzy just trying to think about it.
Next one comes from Anonymous. Also, would a U.S. Space Force help or hinder attempts to find solutions to this space trash problem? I believe that's pronounced Space Force.
So here's what I think. I don't know why they're creating the Space Force, what its mission is going to be, but here's what I can say. Back to a domain that is mostly unmonitored. At some point, people crossing from one coast to the next needed some protection, people to ride with them to safeguard them. People on the oceans needed people to travel with them to safeguard them. If the mission of the Space Force is to provide safety for people to just operate in benevolence, then that's one thing. So in that case, kind of like a Coast Guard kind of activity, that might make sense. But if it's not that, then I don't know what sense that would make.
Next question comes from the girl with the frisbee from ... And it's a similar question that others have been asking. So it's kind of a two-part question. One, explain why the Earth isn't flat. And two, what's the funniest email you've gotten from a Flat Earth Society member?
Why the Earth isn't flat. Well, so here's the thing, right? It's like the way in which galaxies and these things were created and given rotation, right? Rotation of masses. It would be very hard for masses, even if amorphous, to rotate and basically just become these things that were just sheets. Mm-hmm. So that doesn't make sense. So from that perspective. The other thing that I'll say about the whole flat Earth stuff is this. Anybody who has a hypothesis, some theory, whatever, that they want to test, here's some general rules. Your hypothesis has to explain past observations, and it has to predict future. And so anybody who emails me with a flat Earth kind of thing, I say, okay, I can give you so-called trajectories of stuff in space, things that we've observed with telescopes and radars, and if you can fit a model that sustains your flat Earth thing to explain the past and tell me where that thing's going to be in the future, A+. And nobody's been able to do that. So, and with the non-flat Earth model, it works really well.
Next question is from Curious About Space. Do you see us developing a Paris Accord type international agreement that would curb traffic, or is there just too much money at risk to get others to agree?
So say the first part of it again.
Do you see us developing a Paris Accord, some kind of like Kyoto agreement, some kind of an international accord that would curb traffic, or is too much money's at stake to get people to sign on?
No. So here's the thing, right? So like I said, the UN Committee on Peaceful Use of Outer Space, 21 guidelines for long-term sustainability. Now, the 93 countries that signed, yes, that makes sense. Each one of those countries should try to make that space law in their own country and then enforce it nationally. That would go a long way.
And this question comes from Julia. It says, what can we do as normal non-professor people to help solve the problem? I guess that makes us abnormal type people.
Yeah, no. That's what it feels like. Nah. So I think step one, aside from just kind of being aware of these things, is you have government officials that you can engage. You can tell them, listen, out of your long list of problems, the space problem is something that we should care about for these reasons. So you can get engaged, be part of advocacy type stuff. You can, at some point, participate actively in the work in the community, in the space debris community. There are conferences, there are symposia, there are workshops. Some of them come here to UT, so mark your calendars. February 19th and 20th, 19th and 20th of February here at UT, we will be hosting the next annual Space Traffic Management Conference, where I'll be bringing the Director of Space Commerce from Washington, D.C., and people from all over the globe here to UT to talk about these problems. So you can meet these people and talk to them and engage. Yeah.
Oh, what a great note to end on. Thank you, Dr. Jah. That was awesome. Thank you so much.